Alright, my little geometry chickadees, here we go. This is the distance and midpoint worksheet. There are basically three different types of problems in this. We're going to break each one down, show you how each one's done, give you the formula for each one, show you how to kind of work the problem so that even if you're not exactly sure why you're doing what you're doing, which I hope you do, but you should be able to mark it, plug the numbers in, and solve it. Kind of the fake it till you make it. So we're going to start off with distance. Okay, distance is on a coordinate plane is how far apart 2 points are. So I think it's about 1 through like 20 are all distance problems. So all of them are going to use that formula right there. That's the distance formula. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Now that may seem like a lot of gibberish, but it's, we'll get through it. So as you can see on number 1, what I'm doing is I'm marking my points x1, y1, x2, y2. Now it does not matter which way you do this. But if I were you, what I'd do when I see a problem or a page like this, I would go through and mark them all. Okay? So I just did the first 6 because all the problems I'm going to be doing are these first 6. But if I were you, I'd go all the way down to the bottom of the page and just mark them all. And that way, I have them all marked. I have my formula up at the top of the screen, or at the top of the paper, and I'm ready to go. So now all I want to do is take that formula and plug in the variables that I marked. So distance equals the square root of, open parentheses, and then instead of x2, I'm going to put 2. Because, well, that's what I have. Minus my x1 is 8 squared plus y2, negative 5, minus a negative 4 squared. So now notice there, what's going to happen is that negative 4 is going to turn into a plus 4. So because the equation already has a negative in it, when I enter in a point that has a negative coordinate, whether it's its x or y, it's going to flip that to a positive. So that gives us negative 6 squared plus negative 5 plus 4 squared, or negative 6 squared is 36 plus negative 1 squared is 1. So the answer to number 1 is going to be the square root of 37, and that's it. And there's nothing more to do. You don't need to put that into a calculator and round it or anything. Square root of 37 is perfectly fine. So number 2, and again, this is my formula right there. x2 minus x1 squared plus y2 minus y1 squared. And then we're going to take the square root. Do not forget the square root. I know it gets repetitive writing it again and again as you go down, but it's important that you keep the square root. If you give me an answer on a test or a quiz that doesn't have that square root symbol, if you, like say on number 1, if you just give me the answer of number 37 instead of radical 37, you would not get full credit. So here, x2, we're going to just drop it down. Negative 2 minus x1, negative 6 squared, plus y2, negative 4 minus y1, negative 2 squared. Math it out. Negative 2 plus 6 squared plus, whoa, that was the wrong button. Wow, it was a really wrong button. Plus negative 4 plus 2 squared. 6 minus 2 is 4 squared. Negative 4 plus 2 is negative 2 squared. That gives me 16 plus 4, or the square root of 20. Now that answers okie dokie. Okay, so if you just want to leave it like that, it's fine. But I want you guys to start thinking about the reduction of radicals. So I think about the roots of 20, and I realize that 20 has roots of 4 and 5. And 4 is a perfect square. So I can break that off into the square root of 4 times the square root of 5, or 2 times the square root of 5. And so that's the distance between those 2 points. So that is the better answer. If you put either one of them into your calculator, you'd get the same answer for both. But the 2 radical 5 is reduced. So it's like saying that 3/9 and 1/3. They're both equal to 0.3 bar, but that 1/3 is the reduced form. So number 3, we're going to go -6 minus 6 squared plus 5 minus 2 squared. So this time I'm just jumping right into it. So I get -12 squared plus 3 squared. That's going to give me -12 squared is 144. 3 squared is 9. So that gives me the square root of 153. Again, that answer's okay. But I also look at that, and we'll go over in class, but I can look at that and see that it's divisible by 9. Ask me why in class, and I'll kind of tell you the trick. So divide it by 9, and I get 9 times 17 equals 153. So that then gives me the square root of 9 times the square root of 17, or 3 radical 17. Okay? So that's how distance works. So that's how those first, 15 work. 16 through, I think I gave you 10 of them, so 16 through 25, have these little graphs. Now all we have to do here, same general idea, except we need to identify the points first. So here we have 1, -2, -1, -2, and we have 3, -4. Take a quick yawn break. So that's going to give us x1, y1, x2, y2. And I'm just going to go ahead and slap it into the equation. So our x2 is, well, that's wrong. That's the y2. Okay, so I flipped it, and that's fine. I did y2 minus y1 plus x2 minus x1. And that would be an illustration of the commutative property of addition. And the commutative property of addition is simply that it doesn't matter which way you add things. So that's going to give me -4 plus 2 squared plus 3 plus 1 squared. -4 plus 2 is -2 squared. And 3 plus 1 is 4 squared. So then I'm going to go 4 plus 16, or 20, and we already went over how the square root of 20 is 2 radical 5. So on these ones, the only difference is that you first have to identify the point, and then you can go ahead and run the distance formula. So 18. Okay, so what if, however, I switched them around? This is a question I get a lot. How do I know which one's the first endpoint and which one's the second endpoint? And here's the thing, it doesn't matter. So, check this out. If I switched them around, so this one's going to be in blue. So now my x1, y1 is 3, -4, and my x2, y2 is -1, -2. So exactly the same as the previous time, just did it, switch the x1, y1, x2, y2. So now when I plug it in, my y2, or my x2, is going to be -1. Minus 3 squared plus my y2, -2, minus my y1, -4 squared. -1 minus 3 is -4 squared, plus -2 plus 4 squared. -4 squared is 16, plus -2 So 4 minus 2 is 2, so then we have 2 squared. We have 16 plus 4, or the square root of 20, which reduces to 2 radical 5. So notice it doesn't matter which way I go. The distance from point A to point B is the same as the distance from point B to point A. Looking at number 18, we have negative 5, 3, and 2, negative 4. So what we're going to do here is label them x1, y1, x2, y2. Now I go left to right a lot of the times, but it doesn't particularly matter as we just showed, you can pick either one. Just make sure you're keeping your x and your y straight. So that gives us 2 minus a negative 5 squared plus negative 4 minus 3 squared. That gives us 2 plus 5 squared plus, and then negative 4 minus 3 is negative 7 squared. That's going to give me 7 squared plus negative 7 squared, or 49. And that's going to give us 49 plus 49. So that's going to give us a square root of 98. Now I know that 49 and 2 are factors because I just did 49 plus 49, which is the same thing as 49 times 2. 49 is a perfect square of 7, so the answer there is 7 radical 2. Again, the square root of 98 is an okay answer. It's not wrong. It's just not as right as we might want it. And moving on. So this is the midpoint of the line segment with the given endpoints. So what we're going to do is we're going to look. Now, if you look in your book, this is what you're going to see as your midpoint formula. You're going to see x1 plus x2 over 2, y1 plus y2 over 2. So you're taking the average of the x's and the average of the y's. And plotting those points. And that's going to be your x midpoint, y midpoint. So see here where I put x sub m, that just means the midpoint. So that means that the x portion, the x coordinate of the midpoint, is x1 plus x2 over 2, the average of the x values. And the y coordinate of the midpoint is the average of the y values, y1 plus y2 over 2. So what we're going to do is we are going to label our points x1, y1, x2, y2. And again, I would go through and do this to all of them. So now, and here's why. Because even if you're not 100% sure on how to do these, right, or why they work, or what it exactly is that you're finding, what I also want to show you, just as the very basic starting point, is follow these steps in order to help you get the right answer. Again, you may not until later in the year, or maybe even next year, or something like that, figure out exactly why all the steps that are being taken, but it's important that you know what those steps are, so that you can sit there, you can kind of, like I said before, fake it till you make it. And so that's really important. So even if you don't understand what it is that you're doing, follow these steps, plug the numbers in the way I'm showing you, and you're going to stand a great chance of getting the question right. And the more you do it, the more then you'll start to understand it. So it's kind of a win-win situation. So once we've got all of them done, we're basically just going to plug them into our equations. So we have 7 plus 10 over 2. That's going to give us 17 over 2. Or the x coordinate of our midpoint is 8.5. The y coordinate of our midpoint is going to be negative 3 plus 5. That's our y1 plus y2 over 2. Or 2 over 2, or 1. Okay, so that's going to be our midpoint. So our midpoint between those two is 8.5, 1. So what does that mean? What that means is, jumped a little bit too far. Okay, so here are, no, that is right. So here are 2 points, 7, -3, and 10, 5. So that's our line, and we're looking for the halfway point. Now the halfway point that we figured out was 8.5, 1, which is right there. So if we look at that point and sit there and go, hey, listen, is that the midpoint? We go, yeah, our math worked. So, going back, so we were there, that was our answer. The x and y ordered pair of our midpoint is 8.51. Repeating that for number 29, we have 4 plus 4 over 2, -9 plus 10 over 2. So what I did there was I set it up kind of the way that you will sometimes see the midpoint formula in the book. And if you run through there, you get 4, -9.5, which is correct. And so, okay, so finally, we have our endpoint given the endpoint and the midpoint. Now this gets a little confusing for people. So what I want to do is I want to show you kind of graphically what it looks like. So if this is our first problem, it tells us that our endpoint is 7, -7, and that our halfway point is 1, 4. So what we're looking for is the other half of that line. Where does it end? So 7, -7 is our endpoint. That's our endpoint 1, so that's going to be our x1, y1. 1, 4 is our midpoint, that's going to be our xm, ym. And we don't know what our second endpoint is going to be. So that's going to be our x2, y2, and that's what we're going to be looking for. Okay, so we know what x1, y1 are. That's our first endpoint. We know what our midpoint is, xm, ym. And we know what our second endpoint is, x2, y2. Now that second endpoint is going to stay as a variable until we can solve for it. Now, when we look at the midpoint formula, we see that it's already solved for the x value of the midpoint. So, again, this is what we want is to solve it for x sub 2, because that's the missing piece. So what we're going to do is we're going to multiply both sides by 2. So we get 2 times the x value of the midpoint equals the x value of the endpoint plus our unknown. I then want to subtract, jumped a little bit far, then want to subtract x sub 1 from both sides, and that gives me 2xm minus x1 equals x2. So what I just did is I took the midpoint formula and I solved it for one of the endpoints. So now all I have to do is drop numbers into that equation and we're good to go. Back up a little bit. Hold on, sorry about this. So when we're looking here, what you want to do, instead of labeling them x1, y1, and x2, y2, you want to label them as x1, y1, that's your endpoint, and then that midpoint is going to be xm, ym. So again, you'd want to go through x1, y1, xm, ym. Okay, all the way through. x1, y1, xm, ym. And now all you're going to have to do is go through and run these calculations a couple times, and you should be good to go. So here's what we have. We know that our formula is x sub 2 equals 2 times x sub n minus x sub 1. And what I'm saying is x sub 2. That sub just means a subscript. It means it's underneath it. So we have x2 equals 2xm minus x1. That gives us x2 equals 2. Instead of xm, we're going to put a 1 down. And then instead of a y1, we have negative minus x1. Sorry, we have negative 7. So that gives me 2 minus 7, or x equals negative 5. Now we have y sub 2 equals 2 times y sub m, which is 4. And then we're going to subtract a negative 7, which turns into 2 times 4 is 8, plus 7, or y equals 15. So that means our new endpoint is negative 5, 15. So let's look at the graph and see whether that works. And it does. See how that point, negative 5, 15, is in the general area where we put it? And I can also then connect a point, look at everything, and go, yeah, that makes sense. The black line and the red line look pretty identical. Okay, so but now, which one are we doing next? So, 34, we're going to go x2 equals 2 times our xm is 8. We're going to subtract a negative 9. So that's going to give me 16 plus 9. And we get 25. For our y, we're going to go 2 times 3 minus a negative 9. Or, sorry, 8. So that is going to give us negative 2. So our point is 25, negative 2. If you have any questions, let me know. Thank you. Have a good night, everybody.